Hello everybody. Today we're looking at water as a solvent of ionic compounds, and we'll look at some vocabulary, some ionic compounds that do dissolve and some that don't dissolve. An ionic compound, as you probably remember, is a compound made from ions. There are positively charged ions and there are some negatively charged ions. So the positively charged ions are called cations and the negatively charged ions are called anions. Here's a little diagram of an ionic compound, and you can see that there are some positive charge ions here and here and here, and the negatively charged ions surround them completely. Here's a negative one here and here and here and here, and those negatively charged ions surround the positively charged ion, and this one here is surrounded by these ones here, and the negatively charged ions, the anions, they get surrounded by the positively charged ones like this and this. So this one gets surrounded all the way around. Now, when the ions break out and get dissolved, they become hydrated ions. So over here we can see a diagram or a picture of a hydrated ion. There's the positively charged ion, and a little bit of attraction occurs between the ion and the negative pole of the water. Water is a dipole, it's got two ends, and the negative end of the water gets attracted to the positive cation, and that releases some energy when those bonds form, and that becomes what's called a hydrated ion. There. And you can also get a hydrated ion with a negatively charged ion, an anion, and the attraction occurs between the ion and the positive pole of the water, like this and this, and so this is a lot of attraction happening here. These water molecules stick to the anion, and it is called a hydrated anion. That whole thing is also a hydrated ion, and that's relatively stable. Now, when an ionic substance dissolves, the ions move out of from where they are, from the material, and they move and they become hydrated. So this cation has moved out from the material, from the compound, and now it's dissolved. It's become a hydrated ion. And the same thing can happen with the anions. They move out, they go into the water, they get surrounded by water molecules, bonds form, and that becomes a hydrated ion as well. Okay, so that material is now dissolving. The ions are moving out into the water and the whole thing is dissolving. Now, sometimes a material won't dissolve, and the reason for that is that you have to remember that there's hydrogen bonds forming between the water molecules like this. Okay, so all these water molecules are actually slightly stuck to one another by the hydrogen bonds which are occurring between them. So if a cation was to try to move out, first of all it has to break away from all the negatively charged ions nearby in the material itself, and then it has to break in and has to break these bonds. Now, if it's highly attracted to the compound that's already in, and those bonds are quite strong, and then the power to break, if there's not enough energy to break through into the water, then it's not going to do it. If the energy is not right, if there's not enough energy for that to escape, then it's going to stay there. The same with the anions. This anion maybe want to break out, but it's already surrounded by cations in the material itself, and if it can't break through this water, okay, so this one can't, if there's too much energy needed to break all these bonds, there's too much energy for this one to break these bonds, then it won't do it and it doesn't dissolve. So a substance that might do that might be silver chloride. So it's AgCl. Silver chloride won't dissolve. the energy required for it to break into those bonds is too great. Thank you.